Hello, everyone, and welcome to another Jakarta Tech Talk. My name is Irina, and joining us today is Konrad Renner, who will be presenting on the topic of observability for Jakarta EE apps with OpenTelemetry. If you have any questions for Konrad as we move through today's presentation, feel free to ask them in the chat or use Ask a Question tab. Without any further delay, Konrad, over to you.
Hi, and thank you for the warm welcome. Hi, everybody on the screen. And yeah, let's directly start into Jakarta Enterprise and OpenTelemetry. As already mentioned, my name is Konrad Renner. I'm working at the company FullStacks in the profession of software architecture. And one of my topics is observability, or get observability into applications at our customer sites. So some personal things of me, if you're interested, and everything, or the direct link to my digital life, you find on GitHub, Konrad Renner. You will also find all the sources or the examples I will present you and what we will code together today on the exact same space. And yeah, please don't mind and get in contact with me if you're interested in another deep dives or something like this. So, but enough from us about myself. Let's go to a short overview of the agenda. First thing will be a rough overview of observability itself, what the term means, and also what's the difference to traditional monitoring. Then I will introduce you into OpenTelemetry and why it's such a great thing. And then we can get over, of course, to how to instrument Jakarta Enterprise applications with OpenTelemetry. And maybe what are the differences to existing, mostly proprietary solutions in this space. And main part of the whole talk will be live coding. Okay, let's talk about observability. Just some definitions. It's the capability to understand the internal state of a system by analyzing the data it produces. It combines, and this one is important, signals to have a holistic, correlated view of a system behavior over time. And what types of signals these are, I will come to it in the next slide. And now the difference to traditional monitoring: by correlating signals, observability surfaces patterns and anomalies that static monitoring might miss. So monitoring tells you when something is wrong.
Yes? Konrad, sorry for interrupting. We don't really see your slides.
I've forgotten to share the screen. Oops. Sorry for this. Thank you. So, do you now see it?
Yes, now it's perfect. Thank you.
Great. sorry for this. Yeah, I think the first slide was not that interesting, just about myself and the agenda. Now it's getting more interesting. Yeah, so last point is the most important one. Monitoring tells you when something is wrong. Observability helps you understand why. And from a developer point of view, I think the last part is the most important one, because we cannot solve a problem if we don't understand the problem. We will just do something, and the results will be something, but not the solution of a problem. So back to the signals. There are mainly three signals. They are also called the three pillars of observability. These are metrics, traces, and logs. And I like this graphic so much because it's how you dig into a problem normally. Because there is some metric. The metric tells you what is happening. For example, slow response times. And if you are into the problem solution, you need to know where is it happening, especially in distributed systems. And this is where trace comes into play. So the complete chain of different operations or even systems which are included in one particular problem. And last but not least, there are logs. These are the, let me call it, the classic possibility to discover a problem, because the logs tells you why is it happening. Maybe. Yeah, but one thing to mention, if you are doing observability in a good fashion, logs should be just the last line of defense. So if traces are built in a good fashion, you should be able to already get all the necessary informations out of traces, and this is why there stands traces and events out of the trace. But let's get back to the challenge, and to the challenge with the existing systems, or with the systems and solutions before OpenTelemetry. So on the left-hand side, you see there is some infrastructure, hosts, VMs, pods, or containers, or what else. There are applications, and then there are logging libraries, tracing libraries, metrics libraries. Maybe these are proprietary, maybe these are open source, and these are normally sending to their own agents, to their own backends, and they cannot correlate data with each other, and therefore it's really complicated to get a holistic view of all the informations you have in your system. And it gets even worse. Think about distributed systems. So this is a picture of our reference architecture for software systems, for distributed system with full stacks. And what you see here is there are some services, and all of these services, or most of them, have different technologies underlying. So yeah, we have some services with Spring, we have some services with MicroProfile, we have even some services with ASP.NET or with Rust. And it's really hard to get all these informations out if you don't have some standards underlying it. Most of the time you have to rely, or often you have to rely on logs, and this could be problematic because of different log formats, or some services are logging in a structured format, some are not, and so on. And it also gets even worse if there is something in between, for example, event streaming with Kafka. So you have asynchronous messaging between your services. So now, what's the solution? The solution is called OpenTelemetry. OpenTelemetry, this sentence is directly from the website of OpenTelemetry.io. It's high quality, ubiquitous, and portable telemetry to enable effective observability. So what does it mean? And especially, what is OpenTelemetry? OpenTelemetry, on the one hand side, is are specs, semantic conventions, SDKs for the different signals, and it's built on top of other standards, which is really, really nice, because you don't have to use OpenTelemetry APIs to get tracing informations out, for example, of an HTTP header, because there is something like W3C trace context or W3C package, which can be read out of your HTTP header without OpenTelemetry. But of course, if you're using it, you get some nice benefits to it. So maybe one sentence, what is package in contrast to the trace context? So the trace context is especially HTTP header or meta information in an asynchronous message, which is ID, which is propagated through the complete call stack of your system. Not just one application, but the complete system, to also tackle the problems of distributed system. And the package is capable of transporting application-defined properties across different systems via standardized headers. I will have a small example later on. And the nice thing of OpenTelemetry, thanks to the build on standards, is you have not just zero code-based instrumentation, for example, via Java agent, but you can also use it directly in your code with code-based instrumentation, thanks to the standardized APIs. And last but not least, there is something called observability as code. And this is really a nice thing, especially if you are in some regulated environments underway, where you have to trace every change and so on, because everything is tracked via your version control system as code, and the OpenTelemetry collector exactly steps in there. It's not just, it's more or less just an executable which is running and which does ETL. So it takes all your signals, your logs, your traces, your metrics, enriches them, combines them, correlates them, and sends them to some exporters, to one or more exporters. It depends on how many backends you want to use. Most of the time, you just want to use one backend, one tool to get everything in one place. But there are, of course, use cases where you want to export to different backends. It's not required. It's no required component, but it's strongly suggested from my side to use it because it makes your life so much easier, and it decouples your application instrumentation and the sending of the data from the corresponding backend. Backend could be, for example, something like Splunk or dashboards or Prometheus could also be some backend, something like this. Okay, so how does it look like now with instrumenting Jakarta enterprise applications? What possibilities do we have? On the first hand side, of course, there's the possibility to include it via Java agent. So this is zero code based. You just start your Java application with -Java agent and tell the Java JVM where to find the corresponding telemetry Java agent. On Kubernetes-based deployments, you have also the possibility to use an operator, an OpenTelemetry operator, and then you don't even have to specify the Java agent on yourself. But be aware, this can break your application if the operator, maybe it can do things which are not supported by your application, especially if you're using runtimes, for example, like Quarkus, which does some things a little bit other that you would expect from traditional servers. So that's not the best idea to use it everywhere, but it can help you integrate systems which you don't have directly in touch. If you can control and developing the system on yourself, I would not recommend it to you. The Java agent case, of course. Yeah, then we go to the OTEL SDK, which is an implementation of the APIs, and therefore it's enabled code-based instrumentation or manual instrumentation of such things. What do I mean with instrumentation? I mean creating traces, read out information of traces, send metrics on the backend, and even enrich logs with tracing informations, for example. And then you have two really cool possibilities in our Jakarta enterprise space or in the Java world. In the Java world, there is MicroProfile telemetry, and with MicroProfile telemetry, you have the possibility of zero code-based instrumentation and code-based instrumentation, and it is a thin layer upon the OpenTelemetry APIs and SDK, and it more or less just standardizes how Java's application servers or Java runtimes have to integrate the OpenTelemetry components so that it's really nicely usable for you as a Java developer. Last but not least. There are runtime specific instrumentation possibilities, for example, micrometer, which is really popular in the Spring world. And the good message is you don't even have to change anything, because there is, for example, a bridge for micrometer, so that you can send your telemetry just over OTLP or OpenTelemetry language protocol and use micrometer APIs if you like. If you're starting from scratch, I think it's a better idea to directly use the OpenTelemetry APIs. But if you have some code which is already with micrometer enhanced, just use it the way you have and send the data with the standardized protocols. So enough presentation, I think. Let's get to coding. Before we start coding, what you will see in the coding example will be built on an epic scene in a well-known space opera. So there is a Vader service and there is a Luke service. Everyone has an HTTP endpoint. The Vader service is trying to cut off the hand or call the cutoff of the hand from the Luke service, and both of the services will send telemetry data through OTLB. So that's it, and yeah, let's start coding. Do you see my IDE? First question. Not that I start coding and no one sees something.
On the top right bottom of the video, there is a button that's called full screen stage. So I would just ask everyone to click it, and then you would be able to see the code really well.
Okay, then I will show you around in these two projects. One of the projects, the Vader service, is an OpenLiberty based project with MicroProfile 7.1. It just got released last week, and I put it into it. Hopefully everything is working. And the second one is the Luke service, and the Luke service is based on Quarkus. So what we will do on the first hand side is just start the runtimes with the existing code. You can see I have these two resources in there, the cut hand resource and the lose hand resource on the Luke side, because Darth Vader will cut Luke's hand and Luke will lose his hand, sadly for him. And these are just simple JAX-RS services, so more or less RESTful services. They are not really RESTful, but never mind. We don't make a talk about REST. And here you have the resource of the Vader service. So where is my terminal? It's here. Right. Then let's just go. I think everything started. Oh, no, I've forgotten to start the Quarkus-based one. Let's check if everything is working. Libit is already up and running. Quarkus should be up in just 4 seconds. Yeah, here it is. Oh, this is the resource. Yeah, great. Now you see there is a response. Now that I cut off your hand, I can tell you the truth. I am your father, or something in this space the saying was. You can see in the Quarkus service already there are some logs in there, as you would expect, but nothing really special, no tracing or something like this. So let's enable the whole tracing stuff. We will start in the Liberty project. And there we have MicroProfile already in there. Of course, you have to configure it in the server XML like this. I don't put out the feature with MP telemetry. Just the easy way. We open up server XML, MicroProfile 7.1. Nothing special at this side. So, but we want to enable OpenTelemetry, and therefore we are going to MicroProfile config properties, and the first thing we have to do is add some variable disabled ports. The option is a little bit strange, but these are the OpenTelemetry standard configuration values for Java-based applications. And if you tell OTEL SDK disabled false, this means nothing else that, okay, now enable OpenTelemetry integration. I want Liberty that he will export the logs to console and OTEL B. OTEL B is the default in transporting telemetry data to OpenTelemetry collector or observability backend of your choice. You can even use the Zipkin, Jaeger, or whatever you like, or whatever exporters exist. But we will just use the standard one, and OTEL B is using as a backend or as a standard the W3C trace context things. We will give our service a name, and it's our wader service. So, and we have, of course, to tell the OTEL exporter, in our case OTEL B, where we want to send our telemetry data. And we will just send it to a locally deployed instance of OpenTelemetry collector. So that's it. We will also already configure the Quarkus part, and as Quarkus is working, we just have to add a new plugin. And in this case, I take IO, Quarkus, and I want, of course, the Quarkus OpenTelemetry plugin. So, and as for Liberty, we have to configure something, not that much, because in the Quarkus way of life, as soon as you are activating the plugin, OpenTelemetry will be active. Only thing we have to do, Quarkus OTEL.exporter.otlb endpoint, and we will also send it to the locally installed local host. What we have to do on the Quarkus side is to enable metrics, OTEL-based metrics and OTEL-based logs. We have to enable them because these are not production grade at the moment, but I think this will change soon, or I hope so. Yeah, that's it. What we have to do. Maybe one last thing. Yeah, that's all. And now we will rebuild our services. In the meantime, I will start on OpenTelemetry collector. So as mentioned before, it's just a simple executable. What I am using here on my machine is devenv to be fast in setting up development environments. So if you are checking out everything from my GitHub account or GitHub project, and if you have installed devenv, you just have to write devenv up, and the OpenTelemetry collector will start for you. It will download the binary, will open up with some default configuration, and so on and so on. You can also I have another one running over there with a single line of config. So processing data, everything is ready. Great. Then let's start Liberty. Let's start Quarkus and see what's going on next. One thing I have to do on the Quarkus side is to tell the log format that I want to have something in the trace. I just write it down. If you are using structured logging, you don't have to do this. I don't need the parent ID, span ID. Oops. So yeah, let's add some time. And of course the message itself. This should be.
Konrad, we have a small question.
Yes.
Is port 4317 open for collecting requests, or is it sending the data there? Then what is receiving it on port 4317?
Yeah. On the collector side, it's open for receiving data, and therefore we are, from the application side, we are sending it there. Question answered. So it's the receiver side. Oh, what I've done now. Log form. I will just keep the log format at the moment. So I haven't. I'll show you the config of the collector. Then it will be clear. So this is the collector config, and this is what I meant with observability as code, because everything is configured in this YAML file. And on the collector side, I have a receiver for OTLB configured, and it has two protocols activated, one for gRPC, one for HTTP. The gRPC one is port 4317, so it receives data via gRPC on port 4317. Then, in this whole OTEL process, there are processes. There's just one small batch processor, nothing special there. And then I have some exporters. One exporter, which is sending to another OpenTelemetry collector, so you can chain them. Then I have a debug exporter to write out debug messages from the collector itself. And then I have exporters for file traces in files, metrics via Prometheus, and so on. This is the section where I configure it, and then you have service pipelines where you activate it for the particular signals. So for example, the collector is receiving traces via OTLB as configured here, and exports it via OTLB, so sending to another collector. Metrics get exported via Prometheus, and logs are written in files. Is the question answered?
I would say yes for now. Thank you.
Great. Here's the problem, I think. Let's restart Quarkus. Okay. So. Now go back to our curl. Again. Everything there? Yeah. Oh, sorry. And on the Liberty side, you already see I have nothing done with the log format. The trace ID is already there. Span ID is already there. So just with the integration of the properties and the activation of MicroProfile, you can use the whole MicroProfile thing or just MicroProfile telemetry as you like. In our case, I've activated all of the MicroProfile sweetness. So now enable also logs or enhance also the logs in Quarkus. Hopefully now I've done it right. It's there. Yeah. Here you can see trace ID, and it's the exact same trace ID as on the Liberty side. So just with this instrumentation of the Quarkus OpenTelemetry plugin and the MicroProfile telemetry feature of OpenLiberty, you already have a distributed trace between two systems. Your logs are enhanced with tracing informations. You have the traces, and you already have also metrics out there. So if we open up OTEL collector, you can see in the trace, should open up. I sent the logs. You will see a couple of logs in there which were sent. And if I'm going to the browser, localhost. So I think it's, yeah, matrix. We see there are some metrics already in there from our look service and waiter service, and we already have the metrics based on, for example, HTTP route. Just with integration of MicroProfile telemetry and or the plugin of Quarkus. Really easy. But what I already mentioned is the integration or the working with telemetry data in the code. So what we will do next is enhance our code with some telemetry data. Let's switch over to our cut hand resource. And the first thing I want to show you is how to add a span event. So let's just go over here and say, so it doesn't make sense. We don't check what's the answer of Luke. In every case, we just say we add an event because Luke will lose his hand. He cannot resist Vader, and it doesn't make sense what Luke will say to Vader. He want to put him on the dark side of the Force, and he will tell Luke the truth. So we add to our span. IO OpenTelemetry span. We take the current one, of course, and we will add an event. And in the event, we will say, oh, Vader told Luke the truth. So and now we have to open up the trace, and I will open up the trace in an observability backend so that you can also see how this will look in an observability backend. And the observability backend of our choice at full stacks is Splunk Observability Cloud, but you can, of course, also use Jaeger or something like this. And there it is already our trace, and there should be some span event. Yes, there it is. Here is our span event. Waiter told loop to truth. The rest, I think most of you will know already such waterfall views of traces. And as you can see there, there's the waiter service, there's the look service with all the interesting informations, maybe interesting information like response times and so on and so on. Everything you see here is pure OpenTelemetry data, nothing proprietary. If I would switch to Jaeger immediately, Jaeger UI, you will see it in a different way, but the informations are exactly the same. Now let's have some fun with baggage, because I think baggage is a concept which is not used that much, not at our customer side, but I think it's a really cool one. And you can, for example, create transport informations, application-defined informations across system boundaries, and maybe create custom metrics, real custom metrics based on application-defined data between systems, which is really, really nice. One thing to mention, don't transport sensitive data via this thing, because it's there are no security mechanisms around baggage. Just use informations in there which you would send over an HTTP header, nothing more. So what we will do is we will transport waiter's current anger level. I will get this out of this random here. Just get the next int. There it is. And now the important thing is you have to send this via an activated scope. So if I would just write there like the span here, baggage.current baggage, blah, 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 nothing will be sent over the wire. You have to create a new context. And we do this here. This is our scope. We will create a new scope out of the baggage, of the current baggage. We use the current baggage, and we will get a builder from the current baggage and put waiter's anger level into the baggage. This is just the current anger level. Dot build dot make current. So that's it. Now we have the anger level in our package, and it will get transported over to our look service. But of course, we want to read it out in the look service, so we will switch over to the look service and read it out. And you don't have to use the APIs directly. You can also directly. You don't have to call it via the static constructors. You can also inject these. So if I'm here, package, get my current package. Now, what I will do is read out. So it is a null label, so I will have to use this one, current package dot get entry value, and I should copy this one. Out here. Oh, sorry. I will just log it so that you can see everything. Waiters anger level. Let's just log out for the first tick. So that's it. Sent. Now on the Quarkus side, there should be a log. Yeah, and we have an anger level of 69, which is transported from the look service, from the waiter service down to the look service. And I told you we could do this in a thing, or we could do this for creating custom metrics. So let's just create a class which will help us doing the whole metering stuff. We will call it opponent anger level metering. For the sake of easiness, I will just make a application scope, and it will be, I will use a gauge in this case. I inject OpenTelemetry meta instance, which is responsible for creating metas for us. And as mentioned before, I will use just the gauge. So we will init it. Post construct, of course. It's really nicely integrated in the whole CDI stuff, not just with MicroProfile. So, and I also think that the API is a really cool one. So I want gosh, and I call it opponent anger level dot of longs. We will set the unit, percentage, and maybe you can add some description. Meters, the anger level of looks opponents, and build. That's it. Last but not least, we have to assign the values. So therefore, add new anger level of a particular opponent, long level. We will send attributes, so you can give attributes. You can extend metrics with dimensions. So one metric can have different dimensions, and this is a really cool thing because you can then in a backend, for example, select for a different dimension, but be aware if you're using some proprietary backend, maybe there can be situations where it will get into your license fees if you do too much dimensions. Dot set level and the attributes. Now switch back to our loose hand resource. There we will inject the opponent anger level metering. This is our metering. And then what we do is use the value from the current package, get entry value. Map it to a long. present. Oops. Just send it to our metering at the angle level, and we will add an attributes with attribute key. We will use just a string key, and we call it loop opponent. And in this case, the opponent of loop is star beta. So that's it. Now you will see some interesting things, hopefully. Oops. Again, send off the request. Think it works. Blah blah. Trace is there. Logs are there. And now we will switch back to our Prometheus instance, or OpenTelemetry collector instance with a Prometheus exporter. This is see, there are already some additional metrics, and now we are searching for opponent. Not there at the moment. This can be some seconds when it's there. So the exporter does not export immediately, or I have a typo, which could also be the case. No metric there. This is strange. Okay, I think I have to restart it because of the new CTIP. Started. Let's send some data. It's not the first one. Yeah, there it is. Opponent angle level. So as you can see, it has now the value of 53. I don't know if it's the last one. No, it's one from another one. Yeah, the Prometheus exporter of the OpenTelemetry collector doesn't send it immediately via OpenTelemetry. OpenTelemetry OTEL pushes information, and Prometheus fetches it. So maybe if I refresh in a couple of seconds, it would be there. So great. One last thing I can show you, and maybe one has seen this line of code with the fire async. And normally async operations are not directly in the same trace because they could start another business functionality, for example. But what we can do is we can create a new span out, or a new trace out of an async operation, and link spans and traces with each other. So luckily I know where this async event, async CDI event got observed. So this is my escape Bespin class where the Millennium Falcon will rescue Luke. And what we will do here is we are injecting OpenTelemetry tracer object or interface, which is the class, or which is the API construct for creating new traces. And of course, we need the current span so that we can link the new span with the current. And it's as simple as we say fork span trace tracer dot span builder. Normally you use the method name so that you can map the informations out of your observability backend or OpenTelemetry with your code. Then we say dot set no parent. And this tells the tracer, hey, I want to have a new trace, which had nothing to do with the current context. But we will add a span link. And to get, we just have to write current span dot span context. We can set span attributes for additional informations, like the attributes for the matrix. We can use it this way. We can also do attribute key, again, loop.opponent, so that we also know in the trace what the opponent cut off loops and get event.opponent. And I say start span. So span is started, but as the same as with the baggage, to really activate it, we have to make it the current one. So again, we have this try catch block, try. We have a scope, and the fork span will be the current one. And because this is so important, we will also add an event to the span, rescued. And finally, we will stop the fork span so that the other one can proceed as expected. Okay, so let's just do some curl. Trace is already there. Great. Escape from Batman. And as you see, the trace ID is another one that in the escape Bespin class, in this log line is another trace ID than in the loose hand resource. And just take this one to our observability backend. Search for the trace ID. And there we have trace with one span. And as you can see, the symbol, there is a span link in there. We have the additional attributes in there. Loop component is staff waiter. And if I scroll down a little bit, I have the span event and I have the span link. And now I'm able to look in a real life example. I can go from a completely different business functionality, for example, in my system, to the original one, thanks to this linking of spans. Just click on it and it will open up the original one, as you see. Yeah. So, great so far. Yeah, that's it with coding. Hopefully, I could provide you some information about the auto instrumentation, the manual instrumentation with OpenTelemetry in your Java applications. Hopefully, I could showcase that it's really, really easy to do nowadays, and it can help you in many different ways. And many of the backend providers, the monitoring solution providers, are already on the OpenTelemetry boat, and I think it will get better and better. And it's a good information for us developers that we have a standardized possibility to do observability with our applications, especially in the nowadays distributed systems. Yeah, last thing I have to say is, may the observability be with you, and maybe we have time for 1 or 2 questions. I don't know. Thank you.
Thank you for this excellent presentation today, Konrad. So just a reminder to everyone, if you have any final questions, feel free to ask them in the chat or use Ask the Question tab. And also, we started a webinar feedback survey. You can see a green button below, so don't hesitate to share your feedback. So let's see if we have any questions at the moment. It seems like there is nothing so far. Maybe we can give a few seconds to everyone to just think a little bit.
And if I overwhelmed you or you are asleep, I don't know.
No, definitely not.
You can just reach out, as mentioned, GitHub, the GitHub link. Maybe I post the GitHub link into the chat, then everyone can open up if he likes. And I think there is also somewhere in the GitHub space links to my LinkedIn profile and something like this. So just reach out.
Perfect. There you go. There is one question. How much performance penalty is expected?
I really waited for this question. So this is not that easy to answer because it depends a lot of how well OpenTelemetry is integrated with your application server or runtime. So the performance, these are normally some milliseconds. If it's high and on a high level, some milliseconds maybe. For example, Quarkus or OpenLiberty, I think bad code makes more performance problems than the observability inclusion of it. It makes another picture if you are using some maybe outdated application servers because they're not that well integrated with the Java agent. It's working, but it's not built for it.
Perfect. So I see we are running out of time. So thank you once again, Konrad, for the excellent presentation. And thank you to everyone for attending. And I wish all of you a great day. Bye-bye.
Bye.